Alzheimer's is a German name. He was a German neurologist, psychiatrist, and in 1907 at a conference, he described a woman who was in her 50s, kind of like still Alice, pre-senile, who lost her mental abilities like her memory, her language. She also became paranoid, thought her husband was having an affair. Later, she became progressively demented, and after about 10 years, she passed away. And Alzheimer said, what's going on? So he got a permission to look at the brain at autopsy. And it was just fortunate that a colleague told him to try a stain, a silver stain, and he applied it on very thin sections of brain tissue from his patient. And he saw things that had never been described in the history of humankind before. He described tangles. So this here is something that's staining with silver. You see the black silver inside a nerve cell, and he called those tangles. We can call them neurofibrillary tangles. And he also saw these little smudge things which stained with silver. And these are changes that occur at the synapse, where one nerve cell talks to another nerve cell. So this is what we use to define Alzheimer's disease to this day, 100 years later. We define Alzheimer's disease as a slowly progressive dementia, but it goes through a mild cognitive impairment stage. And it may start 10 or 15 years before there's even symptoms. And it's associated with these plaques and tangles. The plaque is made up of many different kinds of chemicals, but a key one is called amyloid beta. And the tangle is made up of another protein, which is called the tau protein. So the hallmarks that we see physically in the brain of someone who we diagnose with Alzheimer's are amyloid plaques, amyloid beta plaques, and phosphorylated tau tangles. Now you might have heard 10 years ago that you couldn't diagnose Alzheimer's until autopsy. Have you ever heard that? Okay, well that's changed now. In the last 10 years, investigators have developed a way of staining the plaques and tangles when people are still alive. And these are called amyloid PET and tau PET scans. So with an MRI scan, which we get very commonly in the clinic, we cannot see plaques and tangles. This is an MRI. We have a beautiful picture of a normal appearing brain. And here we have one that is shrunken. We call it atrophy. And this particular part of the brain, called the hippocampus, is our memory recorder button. Some of you remember tape recorders? Kids down don't know what a tape recorder is. I told you, take it, open it. What's this? What's this cassette for? But we remember the red record button. And so I say that the hippocampus is like the red record button in the brain. And the tangles that Alzheimer described that are made of that protein called tau, phosphorylated tau, those problems start in the hippocampus, in the recorder button. So one of the first symptoms of Alzheimer's is not being able to remember new information. Where's my car parked, Mike? Where's your car parked? Which is the way out of here? These are things that we have to be recording new memory and new time. And in an MRI scan, we can see that there's atrophy. You see, this hippocampus looks atrophied here. And there is atrophy of the brain in general. But we cannot see plaques and tangles that Alzheimer described in an MRI scan. at least not yet. But we can see them with PET scans. This is not your cat or your dog, but this is a PET scan. PET stands for positron emission tomography. Sounds like data in Star Trek. Positron emission tomography, PET scan. Here we're using, the chemist makes a tracer that will bind to amyloid or bind to tau. So the chemist is designing a tracer and tags the tracer with a radioactive label so that when the radioactivity disintegrates, it produces two positrons, and they fly off at 180 degrees, and there's a big donut ring that senses that two things are 180 degrees apart, so it can say there must be a source here, and that way you can say how much tracer is binding to amyloid at any point, or how much tracer is binding to tau. So in that way, we can see here amyloid in pink here, or tau in pink. So in this way, we have learned that amyloid starts to build up 10 to 15 years before there's symptoms. And we've learned that tau starts to build up about 4 to 5 years before there's symptoms. So this sounds scary, but we now have used this information to provide a window to say, okay, let's start treatment. We'll first have to start with our clinical trials. Let's start treatment even before there's symptoms. So you might hear people saying now, it may be easier to prevent Alzheimer's than actually to treat it or cure it. We want to do it all, though. Okay.